In thermochemistry, we talk a lot about heat transfer, and more often than not, we shorten it to simply heat, and we give it a symbol Q. In everyday life, heat and temperature are used interchangeably. However, in physics and chemistry, heat has a very specific definition. It is a transfer of thermal energy from a body of high temperature to one of lower temperature. Let's look at these two blocks. So the red block is a hot block with T red, some sort of temperature, and the blue block is a cold block with T blue, some sort of colder temperature. So we can say that T red is higher than T blue. What will happen over time? The heat, Q, will transfer from the red, hot object to the blue, colder object. And if this goes for some time, eventually some sort of thermal equilibrium will be reached where T red equals T blue. Now, you have actually experienced this yourself. If you step outside on a cold day, what happens to you? You get colder. That is because your body heat is being transferred from your body to the environment. Now, you may wonder, can the process go the other way around? So, could I have heat transfer from the cold object to the warm object? And the answer is simply no. You cannot do that. That does not happen. It is not something we observe. And think about it. What would that mean? If that were the case, over time, the hot object would get even hotter because heat is being transferred towards it. And the cold object would get even colder because heat is being transferred away from it. So you would have that T gets much bigger, T red gets much bigger than T blue. And this is simply not something we observe. Now you may look at another example. Let's say you have a glass of juice. It's at 20 degrees and you put in some ice in there. What happens over time? Well, we've seen it. The ice melts over time. That is because the heat of the juice is being transferred into the colder ice cube, and the ice cube melts. As a result, the juice gets colder because it is losing heat. However, if the process were to go the other way around, so if the heat was being transferred from the ice cube to a warmer juice, what would happen? The ice cube would get even colder, and your juice would actually get warmer. Once again, this is simply not something we observe. So it is important to understand that the heat transfer always occurs from a body of high temperature to a body of lower temperature.